So notice the theme there. I went from the East Coast to school. Now I live in the Midwest, and I do most of my project work on the West Coast now. So I've really traversed the country. So what I'm going to talk about this afternoon is somewhat of a unique topic, but I'm going to tie in all the themes that we've heard earlier today. So keep those in mind. I am a microbiologist and a passionate technology applicator, so I am going to spend a little bit of time on the remediation technologies. But the title of my talk is The Environmental Liability Transfer Sites Well Suited to Combined Remedies. And what on earth is an environmental liability transfer site? Well, let's take a look. Okay, this is something that many of you may not have experienced. This is a unique type of project, back in the 90s, there were several different firms that would buy environmental liability and then attempt to reach closure on those environmental projects. The field has lessened quite a bit. You might imagine it's a risky business, and the risk in those types of businesses can be staggering. But with good information, a lot can be accomplished on these types of projects. So in an environmental liability transfer, there is literally a transfer of the liability to the buyer and an indemnification which protects the original site owner and its employees. There is a commitment to closure, and there's usually some kind of a time frame associated with all that. So these sites are not just, well, we bought it, now we can just keep working on it. It's 5 years or it's 10 years, so the clock is ticking. And when the clock is ticking, there's also a financial sum at risk there. The way these deals are set up, there's a pot of money that's effectively negotiated for the liability, and then there are either milestones or there's just a direct run to try to close the site and assume those monies. And effectively, there's often a percentage of those monies that are withheld until the final closure is obtained. So you might use up 75% of the money, but that 25% looms out there until the closure is actually reached. So anyway, there is insurance associated with these projects. There is still such a thing called cap insurance, which protects the project from overruns. That's extremely difficult to get. Some of these packages or portfolios of these liability sites, they also come with other types of pollution liability insurance. So it's a fairly complex deal, and no one goes into it blindly. I have hundreds of these sites I'm working on now around the country. They're often convenience stores / gas stations, although the latest fashion is industrial sites packaged up. 1, 2, 3, 4 sites. The portfolios are changing over time. There's quite a bit of probabilistic risk modeling that gets done at about an 80% confidence level. That's the magic number. So we don't go in blindly to these sites. We consider the risks, and that's how an environmental liability transfer is structured. So now that you know what that is, now we get back to what we've been talking about all day so far, and that is you need good information to effect a closure on a site. This is a classic figure used in many, many presentations around the country. I like to use it in that it's circular and it creates that wheel of information. And it's very, very important to have each and every one of those pieces because that affects your overall decision making. Not only your overall strategy, but your individual technology selections. What is going to get you to closure fast enough to meet the time constraints in an environmental liability transfer so that you can assume the lucrative pot of money that sits at the end of the rainbow. So all that leads, all that information, all of what we've gathered, and we've talked about it countless times today, the conceptual site model, or the site model overall. And the site model, does it look like a cartoon? Yeah, it's a cartoon, but it's a powerful cartoon. It's simple images that portray the goings-on at the site, and it is dynamic. There's no such thing as a static conceptual model. The conceptual model is always changing based on what you learn, and every time you have a new piece of information, it behooves you to update the conceptual model. So cartoon in nature, but powerful in terms of information. And then you manage your remediation to that. Now, the site I'm going to talk about in my case study today is a typical gas station. And what's a typical gas station? People have this mindset that a gas station site is small, it's simple, we can skimp on it, save a lot of money. You know, it's a fairly easy cleanup. Not true. Not true at all. In fact, you know, all gas station sites, they have a source area, maybe multiple source area, waste oil tanks, dispensers, tank areas of the site, other areas related to the mechanics area for the site. So they all have site source areas, and they all have LNAPL. Now, whether it pools up or whether it's there as ganglia, all these sites have LNAPL present in some capacity. Best to find that as early on in the remediation process as possible, because it can sneak up and bite you. Even though it's a real small footprint on a gas station, LNAPL can come into play at any time. Plumes do migrate off-site from gas stations, as is well known. They tend to get dilute very, very quickly. And we don't see a lot of very long gas station plumes. We see they do get off-site, but we see them as somewhat shorter plumes that start to attenuate. But you see very robust concentrations on-site and lots of sorbed face material. So you can't overlook any of that. So I like to start with information. So field parameters, all those things are important. I have technicians, they'll ask me, well, should I skimp on a couple of these parameters? No, never. Collect the data when it's available. So if you can get pH and you can get conductivity, temperature, ORP, dissolved oxygen. You know, I talked to Peter before after his talk, and one of the things, if we'd had more time, I was going to ask the question, what were you seeing in terms of temperature on that microbiologically active site that he has? Well, he's seeing very high, let's call it extraordinarily high temperatures. All those things are factors in your remediation decision-making process and how you combine remedies. So these are not things to be skimped on. It just seems so easy to omit things. All these parameters are valuable. Also, electron acceptors, understanding what are the electron acceptor geochemical conditions on a site. What's nitrate look like? What's iron look like? Sulfate? What is methane? What does carbon dioxide look like? All those things interrelated and then coupled with an evaluation with field parameters help shape your decision making on the site and which remedy makes the most sense for the site. And I'm a microbiologist, so I do microbiology on every site. And you saw Jim put up my quote before, and I mean it. It adds money. It absolutely adds money to the project. But it's important because if you can track the microbial footprint across a site and understand changes, and they don't always occur, but when they do occur, they provide valuable information and are very critical to that whole shaping of the conceptual model on a site. So, big fan of the biotraps. If you want to go a little bit lighter, a little more of a quick hitter approach, the little bioflow filters, also very useful tools. And the microbial analysis can be scaled to different cost levels. You can do some very basic analysis and get some information. You can do much more elaborate analysis and get much, much more information. So again, my message is don't omit this very important category. You can get tremendous information from it. You can even use this particular type of analysis for troubleshooting should you run into some issues on a site. And that's another talk for another day. And all the tools again. Have we talked about tools today? Whether it's HPT or it's MIP or CPT or what have you, or all the other tools that were mentioned in the numerous talks. They're all valuable. I'm just going to mention one more that I don't think anybody keyed on, and that's the water injection test. Since I do a lot of injection of fluids around the country, you know, I always go out and do a water injection test. 50, 100 gallons of water, seldom very much more than that. And I just see how the site responds. And we may get into that later, but the water injection test even can be oversimplified. It can give you tremendous detailed information. So I would encourage people, if they're going to inject fluids, that they should attempt a water injection test and carefully look at the data from it. Now we get on to the remediation toolbox that I so love. So biological, we've got chemical, we've got physical techniques. Many of you are more familiar with certain techniques than others. Every site, when you're doing remediation, has some sort of a layout or some sort of a grid. This just happens to be from a direct push application. All these red and black dots are injection locations that occurred through various injection events. And so these are important grids to maintain on sites. You can run letters across one axis, numbers across another, and create your own little series or spreadsheet of injection locations. And you can get information from each and every one of those locations. So I like the grid method. I like to see it. And then I like to dip into individual points because then it matches up with your injection report that you get from your contractor or your field notes that you get from your field tech. These are so valuable. Most people take these and they throw these on their desk and never look at them. But if you look at the individual points and you look at the data associated with them, you can see differences. You can see when the flows are different at a point or the pressures are different, or if there's some sort of oddity that occurred at an individual location. That will tell you more about further remediation work, may even cause you to shift your thinking onto another remedy. So on to the case study, and I think we'll be good on time here. This is a Garden Grove site, which I'm happy to say reached closure recently, following the low threat closure guidance. And it's an active service station. It has, like most sites, mixtures of lithology. Did we know everything there was to be known about the lithology going in? Absolutely not. Did we know a whole lot more by the time the site was done? We certainly did. And that's ultimately what led us to close it as an environmental liability transfer site before the deadline was up. So very critical. So it had, before we even got hold of it, traditional excavation and a pump and treat system to manage plume migration. That's all that was being done at the site. When we got hold of it through the environmental liability transfer mode, we added in SVE, we added in air sparging. We ultimately evolved and converted that over to an ozone sparging system till we ran that till it could do no more for us. And then we were able to polish it off with some other direct push ISCO injections, and then lastly some aerobic bio set within some very surgical excavation. So look at the list. How many different technologies or approaches were employed here to ultimately get to closure to meet a very specific objective? CPT for us was the key. We learned a tremendous amount by implementing the cone penetrometer later on in the game at this site. Helped us understand the lithology a bit better, helped us find some stored mass that we hadn't found before, and was a very, very useful tool in the overall process. So ultimately, the site met the needs for specific criteria. We were able to get a stable and decreasing plume that was GRO, benzene, and MTBE. And then we were able to get an exception for the soil vapor intrusion because this is an active service station, so we're able to get that exception. And soil sampling post-SVE for direct contact and outdoor air exposure met any guidelines we needed to hit. So these were all the different elements that went into the success at this site. We did think about other things at times too. We never took any technology too quickly off the table. And other things we thought about some very creative soil removal techniques, slide rail shoring techniques that are very surgical type excavation techniques. We thought about in situ soil blending with a unit that looks like this, and also with a soil auger that we could apply amendments to the subsurface. Those things were on the table for a while. The logistics of the service station site took them off the table. We thought about in situ heating for a while, a very successful, comprehensive technology. Again, just the logistics of the site, weighing the costs. It was on the table but came off the table. And again, we thought about additional ozone sparging, perhaps with a larger ozone generating unit. Oftentimes with gas stations, there's a tendency to undersize the ozone sparging unit, so we considered a much larger unit to put on site. Ultimately, we went with a much more straightforward approach, and that's ultimately what wrapped up the site. This was the entire site that was treated. You can see some of the different areas, the dispensers and the underground storage tanks. This is what we were left with at the very end. It's this part of the site here. And we wound up excavating 2 small areas in the back of the site and did a small grid of ISCO injections in this area. So those technologies I just showed you were in consideration out here. These excavations, we were able to layer the base of them on a 0.2% weight basis with ORCA pellets. So we generated oxygen and we did aerobic bio in a halo just around these excavations. And then in this area here, we did a grid of persulfox, an all-in-one ISCO material, which is persulfate that's self-activating. Love that because it's much, much easier handling than traditional ISCO. And we were able to actually do just a single injection in this area, which is very unusual. Usually it's 2, maybe 3 injection events. We were able to do a single injection because the CPT had showed us specific zones that we needed to target, and by shrinking down that vertical interval, we were able to hit it with a really high-strength persulfox solution. We went to 20%, which is much, much higher than what we normally do, and that was good enough to get us done. Again, you can see some of the logs here that show the variability. You can see these little sand seams that are interspersed here. Again, you know, the devil's in the details. All those little sand zones that can be transmissive, but you have to couple this information up with other pieces of information. If you don't hear anything else I say, I'm a big fan of looking at lots and lots of varied data. I don't ever look at one single parameter or 2 or 3. I look at everything in its entirety. And again, some other views from across the site. Again, we see that variability that exists on so many sites and just helps with that targeting. If you can target your remedy, you're going to be successful. If you go at it broadly, you're going to lose so much remediation technology, so much chemical to areas where you don't need it. Here we use the MIP to help us draw a footprint of some of the areas that we were going to target. Again, these were the excavation areas here. This was the area here that ultimately received the ISCO injection. And then we see it kind of from a profile standpoint here. And some of the other mass storage areas that were found in the subsurface. So shape it, color it, put it out there any way you want, as long as you're able to understand it and build a good conceptual model from it. It's going to get you where you need to be. At the end of the project, we had met the soil remediation conditions for the site. You can see, which is always nice to see, a lot of non-detects, some very, very low numbers, and around these areas of concern, the Spencer Islands and UST areas. I love this right here. A lot of non-detects in the soil right around the USTs. The groundwater, too, from the monitoring locations we had. Ultimately, we wound up leaving concentrations in the ground that were in these ranges, depending upon the area of the site, depending upon the risks associated with where those concentrations were found. We used Mann-Kendall statistical tests to back up the data that we had to show decreasing or stable trends. Recommended highly whenever you have a robust data set. It's something you can incorporate with all the other data that you have. And then trend graphs. Trend graphs tell us a lot. They can get a little bit busy, but it's always nice to see them marching downward as you go. And we did these for each and every one of the performance wells. So we had your standard data, your trend graphs, your Mann-Kendall tests, and then ultimately this site went to a series of closure criteria. And these follow the low threat closure guidance. You know, what's the history and land use of the site? Did we have a complete investigation where we delineated in all directions, particularly vertically, the often forgotten one? What were our pre- and post-remedy data? What was our results of our SVE and all that occurred associated with it? Were all of our site maps accurate? What was the disposal history of our site from cuttings and fluids and whatnot? What was our final well inventory? What wells were abandoned? What wells were still in place? What was our geotracker status? You heard that mentioned earlier. And then how much residual mass was present in the subsurface? And what kind of risk, if any, would that mask pose? So a very critical criteria to have met. And then lastly, who are the property title holders? We're very pleased now to be able to say within our time frame, we're going to get to turn it back over. And we will collect a tiny sum of money because we're able to meet the closure criteria. So lessons learned as I wrap this up with 6 minutes. I'm working it, Jeremy. Invest in your CSM, whatever that takes, whatever you need to do to free up monies to collect good data, have good people associated with the project, get a good hard look at all the data, not just pieces of data. Collect microbial data, because I'm a microbiologist and I said so. Microbial data can be the sleeper out there, can tell you things about your site that you may never have realized before. And it's a very, very important piece of information to complete that information wheel. Be open-minded to various options. You saw how many technologies were put in play. Consider them all till you can't consider them any longer. And then lastly, manage your remediation to risks. What are the risks that you encounter? Always be cognizant when a remedy is applied to a site. What can I do to affect a given risk? Because that's truly what it's all about. So it's about dollars, it's about data, open-mindedness, managing to your risk.